Online courses have widely evolved over the years. MOOC videos don't support immediate feedback like classroom learning. There are a number of online courses that are available these days. Expect the students to be listening attentively to what's happening in class. But on the flip side, there could be a lot of other things that could happen. The students may be scared to ask doubts, or they could have dozed off in front of the laptop, or they could have not followed the lecture and be confused about the subject. So we decided that we could tackle one of these subjects, which is confusion. Hello everyone, this is Team Aayana.
And our topic is analysis of brainwave signals for confusion.
The EEG test process is simple and it takes about 40 minutes. The head is precisely measured and markings are made in order to install the electrodes. The electrodes mounted on the chest are used to monitor the heart rate, and those on the head are used to monitor neural activity. The actual EEG recording process is then initiated in order to collect the various brainwave signals based on neural activity. Various tasks in our experiment, watching of videos, are then performed to record brain activity.
On performing the EEG test, raw signal data is obtained. By further processing it, the parameters in our dataset can be obtained. The dataset has the following features. The first parameter is the subject ID, which denotes the student number. The second parameter is the video ID, which denotes the video number. The third parameter is the attention, which is a measure of mental focus. The fourth parameter is the meditation, which is a measure of calmness. The fifth parameter is the raw EEG signal. The next 8 parameters represent different bandwidths of brainwave signals. The delta band consists of brainwaves which are generated in deepest meditation and dreamless sleeps. The theta band consists of brainwaves that occur most often in sleep but are also dominant in deep meditation. It acts as a gateway to learning and memory. The alpha band consists of brainwaves that are dominant during quietly flowing thoughts and in some meditative states. The beta band consists of brainwaves that represent a state of consciousness when attention is directed towards cognitive tasks such as problem solving and decision making. The gamma band consists of brainwaves that relate to simultaneous processing of information from different brain areas. Band 1 represents frequencies of brainwaves of lower power spectrum, while Band 2 represents frequencies of brainwaves of higher power spectrum. Last two parameters include predefined label, which denote if the student is expected to be confused, and the user-defined label, which denote if the student was actually confused. The dataset was read in columns subject ID, video ID, and self-defined label were removed. Principal component analysis was performed on the dataset to determine the most contributing factors. Predefined label was not found to be a contributing factor, hence it was removed from the dataset while building models. Student 6 was removed from the dataset as he contributed to noise, as evident from the plot of value of raw against the value of sample for all subjects and videos.
After predefined label and recordings related to subject 6 were removed from the dataset, a number of models were built and the student independent technique was used to calculate the accuracy of these models. The results obtained were as follows. The decision trees model gave us an overall accuracy of 56.36%. C5.0 algorithm gave an accuracy of 51.83%. Random forest gave us an overall accuracy of 57.93%. K nearest neighbor gave us an accuracy of 58.89%, the highest in student independent analysis. Naive Bayes classifier gave us an overall accuracy of 52.89%. Boosting algorithm gave us an overall accuracy of 56.69%. The support vector machines gave us an accuracy of 58.11% on an average. In order to obtain a clearer picture of how these models performed on the dataset, we thought, why not perform the random testing? The dataset was divided in the ratio of 60:40. The larger part being used for training and the smaller part being used for testing, and the results that were obtained are as follows. KNN gave us an accuracy of 59% on an average, SVM gave us an accuracy of 63% on an average, and Random Forest gave us an accuracy of approximately 66%. Clearly, SVM and Random Forest perform better than KNN. This is mainly because SVM and Random Forest don't overfit the data. Random Forests and SVM are excellent performers for two-class predictions. Also, Random Forests perform bagging. This gives weighted average to the trees it constructs. Hence, this helps in providing an improved accuracy of prediction.
In our study, we found that the random forest classifier indeed provided us with the highest classification accuracy of 66.87%, whereas the student independent classifiers in the paper could achieve a meager classification accuracy of just about 51%. However, if a much more detailed study were to be performed, we would definitely be able to achieve a much higher accuracy rate. Electroencephalography could therefore be deployed with massive open online courses to detect the confusion level of a student while watching an online video, and hence be able to predict the confusion level with a high level of accuracy, and its deployment would nonetheless prove to be a huge breakthrough in enhancing the student-teacher interaction in e-education.
The contribution of each team member to the project were as follows. Hemkesh V performed the literature survey of paper, exploiting EEG input in a reading tutor. He also implemented the naive-Bayes algorithm and the boosting algorithm. Jeevan Nagraj performed the literature survey of paper, brainwave recognition of words. He was also responsible for the implementation of principal component analysis, cleaning of the dataset, and the implementation of algorithm support vector machines on the dataset. Pooja Balusani was responsible for the literature survey of paper, I think, therefore I am, usability and security of authentication using brainwaves. She also implemented the decision tree and C5.0 algorithm on the dataset. Prateek Chatterjee performed the literature survey of paper, classification of EEG signals from 4 subjects during 5 mental tasks. He also implemented the random forests and the K nearest neighbor algorithm. All team members equally took part in discussions and decision making.